875 words, within the 900 plus or minus 5% target range. Here's the final script. Right now, a planet is still being crushed into pure diamond 7,200 light-years from Earth, and astronomers at Caltech have no way to stop it, or even fully explain how it survived. It orbits what used to be a star. Now it circles a corpse, a pulsar spinning 10,000 times a minute, so dense a teaspoon of it would outweigh a mountain. And every 2 hours, this diamond world sweeps past it again. Scientists gave it a catalog number, PSR J1719-1438b, but everyone who has studied it calls it something else. The Diamond Planet. And what they found buried in its data is the part they still won't say plainly on camera. Picture a star 5 times the mass of our sun. Now picture that star dying not quietly, but violently, collapsing into a pulsar, a stellar corpse so extreme it bends the rules of physics just by existing. Somewhere close to it, a companion star and a binary pair got eaten alive. Slowly, piece by piece, over millions of years, its outer layers were torn off and pulled onto the pulsar until there was nothing left to strip. What remained was the core, peeled down to almost nothing but carbon and oxygen and packed into a ball smaller than Jupiter, denser than anything that should still be called a planet. Astronomers first caught it in 2011 at the Parkes Observatory in Australia as a strange, rhythmic wobble in the pulsar's signal, a tug from something small, dark, and impossibly heavy, hiding right next to a corpse that should have destroyed it. Under that kind of pressure, carbon doesn't stay carbon. It crystallizes. It becomes diamond, not a sparkling gem, but a solid, planet-sized lattice of crystallized carbon, denser than any diamond ever pulled from the Earth. When the team at Caltech ran the numbers in 2011, the density didn't fit anything in their models. Too heavy for its size, too small for its mass. There was only one explanation their equations would accept. This world had been squeezed past the point where carbon can exist any other way. Here's where it gets stranger. A pulsar isn't just dense, it's violent. It blasts out radiation, X-rays, a fire hose of energy that should have vaporized anything nearby a long time ago. This planet orbits at a distance closer than Mercury is to our Sun. It has survived that bombardment for what may be billions of years. Nobody at Caltech or Manchester, where the pulsar's signal was first caught, has a clean answer for how a crystallized core that small holds together under that kind of radiation without being stripped apart, atom by atom, into nothing. But that's not even the part that worries them most. Here's the detail almost no one outside the research teams talks about. The Diamond Planet isn't alone. Roughly 40 light-years from Earth, there's another candidate, 55 Cancri E, a so-called super-Earth that some researchers believe may also carry a crystallized carbon interior, possibly worth more in raw material than the entire economy of planet Earth combined. Two completely different systems. Two completely different death spirals. And in both cases, the same impossible signature. Carbon, under pressure no laboratory on this planet can replicate, forming lattices we can only theorize about from a distance of trillions of miles. If crystallized carbon worlds are common in the dead husks of exploded stars, that means diamond, the rarest material we know, might be one of the most common outcomes in the universe when a star dies badly. And if that's true, then everything we've built our sense of value around scarcity, rarity, worth was only ever a local rule. A rule that applies here on this one planet and nowhere else we've looked. A rule the universe never agreed to. There's a colder implication underneath that one. If a planet can be compressed, stripped, and reborn as something unrecognizable, orbiting the wreckage of what killed it, then planets aren't fixed objects. They're processes, stages. Our own Earth, our Sun, everything you're standing on right now, is a snapshot in a much longer, much stranger sequence that doesn't end when a star dies. It just changes form. Caltech's own researchers have admitted carefully off the cuff that finding one diamond planet was a fluke. Finding a second, similar signature light years away means it might not be rare at all. It might be a fate. It might be what's waiting, eventually, for worlds we haven't even discovered yet. So the diamond planet keeps circling its dead star, once every 2 hours, exactly as it has for who knows how long, unbothered by the fact that we've finally noticed it. Nobody at NASA, Caltech, or Manchester can tell you how many more of these worlds are out there, quietly finishing the same transformation, unseen, in the dark between the stars we've already mapped. If crystallized carbon is the default ending for stripped planetary cores, what does that mean for the ones still forming right now, in systems we haven't even pointed a telescope at yet? Tell us what you think is really out there, down in the comments.